Hello students! Hello students, welcome to my channel. You all know me. My name is Tofik Naik, and in this channel I teach you physics, chemistry, maths, biology of 11th and 12th class for IIT, JEE, NEET and all. So we have discussed many topics in chemistry and physics. In physics, we have discussing a beautiful lesson which is motion in a straight line. So in that we have completed some part. We have left with last topic which is known as relative velocity. What is this relative velocity? We'll discuss this relative velocity in this class, and from next class we'll discuss all the important questions for NEET CET in this class, in this video. So let us start without wasting your time. Relative velocity. Students, always remember one thing always relating to another thing is called relation. For suppose you are in a train. Just imagine you are in a train. Okay, you are in a train going in this direction. Okay, you stand here and see everything from the outside. Okay, you are seeing everything from the outside with your point of view. That is from your reference. From your reference, you are seeing everything from this point. And a person standing in a road, seeing you and your train moving from one thing to other thing. This is his point of view of seeing you. And now suppose imagine another train with the same speed of you. Okay, with the same speed of you is moving in this direction. This is train B, and this is train A. So now you are in a train A and your friend is in train B. You both are seeing with each other. You both are seeing one another. Like you are standing here and seeing outside. You are observing another train moving with same velocity. Okay, let's imagine the velocity of this train is, and this train also velocity of this train is. Okay, for suppose imagine. Okay, now you are both are moving in same direction, same velocity. So what you will see? You will observe that you are not moving. You are stationary. You will think, you will observe like you are stationary, but you are moving. ये कैसा होता है ना? पता, जस्ट सिंपल. अब ये दो ट्रेन एक एग्जैक्ट पोजीशन पर आ गई, एक कांस्टेंट वेलोसिटी से मूव कर रही है. इसके अंदर रेड के अंदर आप खड़े हो, इसके अंदर आपके फ्रेंड खड़ा हुआ है. तो इस दोनों इस तरह मूव कर रहे हैं. तब आपको क्या लगेगा कि मैं भी स्टेशनरी हूं, मेरा फ्रेंड भी स्टेशनरी है, हम मूव नहीं कर रहे हैं. इस तरह आपको इमेजिनेशन इलिस्ट्रेशन होएगा. बट जो इंसान इधर खड़ा होगा ना स्टेशन पर, उसे क्या लगेगा? आप दोनों की स्पीड उसे ऑब्जर्व होगी. आप दोनों यूं जा रहे हो तो आपको क्या लगेगा? आपको लगेगा कि दोनों सेम जा रहे हैं, सेम है, ये मूव नहीं हो रही है, इस तरह लगेगा. लेकिन इस पर्सन को आप क्या लगेगा? इस पर्सन को लगेगा कि मूव हो रही है, वेरी फास्ट मूव हो रही है. इस तरह पॉइंट ऑफ व्यू रेफरेंस अलग होती है. इसी को हम कहते हैं रिलेटिव वेलोसिटी. जिस तरह इस पोजीशन पर आपकी रिलेटिव वेलोसिटी अलग थी, इस पोजीशन पर आपकी रिलेटिव वेलोसिटी इन दोनों की मैच करती थी, लेकिन आपकी रियल रिलेटिव वेलोसिटी इससे कुछ अलग है. इस तरह के रिलेशन को हम कहते हैं रिलेटिव वेलोसिटी. नाउ लेट अस ऑब्जर्व सम डेरिवेशंस अकॉर्डिंग दिस. ओके स्टूडेंट्स, जस्ट सिंपल है यारो. जस्ट आंख बंद कीजिए और इमेजिन कीजिए कि आप एक ट्रेन में हो, आपका फ्रेंड दूसरे ट्रेन में विद सेम वेलोसिटी मूव कर रहे हैं. तब आपको क्या लगेगा कि आपका फ्रेंड भी सेम आपकी बाजू ट्रेन में मूव कर रहा है. तब आपको क्या लगेगा? एक लाइवलीहुड का एग्जांपल देता हूं. जैसे कि आप कहीं पर टूर गए हो आपके टूर, तो आपकी कार जा रही है, आपकी फ्रेंड की कार भी आई बाजू. तो आप क्या करेंगे? दोनों में बात करेंगे. बाजू कार जा रही है तो आप दोनों में बात कर लेते जाओगे ना. बात कर लेते जाते आपको क्या लगेगा कि हम मूव नहीं कर रहे हैं, हम एक ही जगह पर है, हम बात कर सकते हैं, वो मेरे साथ है. इस तरह फील होगा. लेकिन बाहर से देखने वालों को क्या लगेगा कि आप दोनों में मूव कर रहे हो, इस तरह लगेगा. ओके, नाउ लेट अस कम टू द रिलेशन. ये हमें क्या होता है? जस्ट इमेजिन कि x of a of naught, x of b of naught, ये क्या है? पोजीशंस with respect to t is equal to 0. ये कैसे होता है? जस्ट सिंपल है. एक ग्राफ लीजिए. अगर आपका टाइम 0 हो तो ग्राफ में क्या डालिए? टाइम डालिए, इधर साइड वेलोसिटी डालिए या फिर डिस्टेंस डालिए. ओके, आपका टाइम अगर 0 हो तो इधर कोई वैल्यू आएगी? नहीं आएगी. इधर आएगी? नहीं आएगी. सिंपली ना, ये क्या होगा? पोजीशन क्या होगा? इधर एक्स ऑफ ए होगा. अगर कुछ t इज इक्वल टू 1 है तो यहाँ आएगा पोजीशन, t इज इक्वल टू यहाँ आएगा। इसी तरह x ऑफ b भी इधर ही होगी, वो नहीं मूव करेंगे। अगर टाइम 0 हो तो पोजीशन भी 0 होते हैं ना। जिस तरह अब मैं इधर हूँ, मुझे उधर तरफ जाने के लिए कुछ टाइम चाहिए। अगर मैं इधर ही हूं, मेरे पास टाइम नहीं है तो क्या होगा, मैं इधर ही रहूंगा ना, तो 0 ही रहेगा। इस तरह ये दोनों 0 होते हैं एट t इज इक्वल टू 0। उसी तरह x ऑफ a इज इक्वल टू t, x ऑफ b इज इक्वल टू t with respect to t at something value, like suppose आपको t की वैल्यू 2 आई है, तो अब क्या होगा, यहाँ का आपका ये पोजीशन इधर जाएगा ना, इधर जाएगा 2, ये पोजीशन क्या जाएगा, इधर जाएगा, d इज इक्वल टू। इस तरह पोजीशन चेंज होगी विद रिस्पेक्ट टू टाइम। आप इसे एक रिलेशन से लिख सकते हैं। जैसे आपको पता है एक वेलोसिटी का रिलेशन है, वेलोसिटी का एक रिलेशन है जो पोजीशन को एंड वेलोसिटी को रिलेट करता है। वो रिलेशन क्या है, जस्ट सिंपल लाइक वो रिलेशन कुछ इस तरह है। फर्स्ट हम x ऑफ a को लिखेंगे पोजीशन में, x ऑफ a इज इक्वल टू x ऑफ a विद रिस्पेक्ट टू t इज इक्वल टू x ऑफ a विद रिस्पेक्ट टू 0 प्लस what you can write velocity time. Okay, this is a relation you have derived in acceleration. Okay, similarly you can write for b also, for position b. Look, okay, you have got very easily at two things, which is about like x is equal to u plus t plus of 8t square. Yeah, इस तरह का रिलेशन से आपको एक्सेलरेशन में आएगा, रिलेशन आया है आपको। तो इसमें हम ये सब्स्टिट्यूट करके इस तरह के डिराइवेशन काढ़िए। इसे हम एक्सेलरेशन को इग्नोर कर चुके हैं। क्यों एक्सेलरेशन को इग्नोर कर चुके हैं, क्योंकि इस थिंग्स में एक्सेलरेशन कहीं भी नहीं आ रही है, तो हम एक्सेलरेशन को इग्नोर कर रहे हैं। तो इतना आंसर आएगा ना। तो अब हम सिंपली with respect to b we will see first, with respect to b we will see first. If you see with respect to t minus just subtracting equation 2 with equation b. How can you write x of b minus x of 0? Okay, similarly for v of b minus v of a of t. Okay students, now just imagine this is a formula you have got for entire system. Okay, now this is formula from b to a when you absorb time from b to a, or when you absorb a thing displacement from b to a. Similarly for a to b, just simple multiply this, divide by, subtract this by this and this by this, easier. For suppose for your reference I can write, okay, I will write, see, okay students, just simple as it is. This is from b to a, this is from a to b. Okay, now we have got position, we have got to know how to find the position. Now we must find the velocities of one train absorbing another train, or one observer in one position absorbing another observer in another positions. So how you can see the velocity? Just simple. Look, velocity v of ab. First we will observe from velocity a to velocity b. First we will observe from a to b. How can you write this? Just simple. A velocity of a minus velocity of b. This gives you this. Okay, you are studying in mathematics. Okay, this relation is satisfied. So now just see, this is equal of, this is what, this is from, how can you write, this is from v of ba and this is from v of ab. Okay students, very easily you got, this is the velocity from a to b. Okay, and similarly for velocity from b to a, how can you write b to a? Okay, very easily you got answers. Now let us find some graphs and the relation between this and this. What will be the relation between these two? How can you derive the relation between these two? Just simple. I can say that just multiply, just make sure to remove negative signs or anything, just like v of ab minus v of ba. You have got, okay, we have written, do addition for your convenience. Okay, do addition. Now just add this v of a minus v of b plus v of b minus v of a. What you will get? These cancel, this cancel. Now finally what you will get answer, v of ab plus v of ba is equal to 0. Now just transfer that to this side. What you will get? You got this kind of answer. If you do addition, you will get this kind of answer. You can similarly do subtraction. That time also you will get the same answer. How? Just see this. V of AB minus v of ba, right students? So is equal to v of a minus v of b minus of v of b minus v of a, right? So just do this thing. V of b minus v of ba is equal to v of a minus v of b minus of v of b plus v of a. So now you can just simply add that one. Okay, v of ab minus v of ba is equal to what you can do? 2 times of v of ab minus 2 times of v of ba. Okay now students, so just simply what to do? Just take the 2 outside. You can write you just take v of 2 outside, which means v of a minus v of b. Yeah. Okay, so v of ab is equal to v of ba is equal to 2 times of v of a v of b. What you can write? V of ab. Yeah. So v of ab, which means transfer this to that side. What you will get? V of ba is equal to 2 times of v of ab minus v of ab. So finally your answer will be like minus v of ba is equal to v of ab. Okay students, if you do, this is for your reference, if you do addition also, your answer will be same. If you do subtraction also, your answer will be same for your convenient additions. Now let us find the graphs which gives the graphical representation. If velocity of one train or one observation is greater than velocity of second object, or velocity of one object is less than, or velocity of one object is equal, we will find that. Okay, now, so come on, let's do this. How? Okay, we have a formula, we derived a formula. What is it saying? It's just saying like this: t minus t is equal to f of x of a is equal to 0 minus f of b is equal to 0 plus v of a minus v of b is equal to t. Is this a formula, right students? This was your formula. Now we'll just see what we'll see 3 cases. What are those cases? Like first case we'll see like when v of a is equal to v of b. Second case we see, right, when v of a is greater than v of b. Third case we see, right, when v of a is equal to positive, v of b is equal to negative. This kind of cases we see. How? Just simple. See, if v of a is equal to v of b, what it will become? 0. If v of a is equal to v of b, it will become 0. Okay. It's just easy. Physics is very easy. Okay. Now just see. V of a minus v of b is equal to t. Okay students, if you substitute these values in this, what it will become? Like it will become like v of a minus v of a is equal to t. What it will 0. So what you will finally get? We will finally get like x of a into t minus x of b into t is equal to x of a minus x of b. And you know, this is value at initial time. This is value at initial time. This is value at some time. This is value at some time. This is value at some initial time. So you can write this kind of, and this kind of. What it is saying? The positions of two observers, two objects is same. If we take a graph with the time is equal to distance meter. So if one observable or one train make a graph this, okay. Suppose imagine if one train make a graph this, then the second train or second object should be make the same graph because it's both are equal. Okay, then second graph will be like this kind of. Okay, very easily you solve this. Now let us see this kind of condition. What they have said, if v of a is greater than v of b. In this kind, just to see if v of a is greater than v of b. Okay, no. This kind is v of b is greater than v of a. Okay. If v of a is greater than v of a, it will become very mess. So this kind, what you will do? Just simple. See, if v of b is greater than v of a and v of a is negative and v of b is okay. If imagine we have taken this 2 and we have taken this value as 4. What it will become? It will become like -2. Okay. Or else we have taken, we have 2 is equal to, this is similarly 2 and this is 8. What it will become? It will become like 6. If we take less value, it will become like 1. Okay. Now we don't need this value. So we have get this value. If we apply V of B greater than V of A, then what we are getting? We are getting negative sign, which means that if we apply, if V of A is greater than V of A, then V of A minus V of B is equal to negative. Negative sign we are getting a clear cut negative sign. I have showed you are getting a very negative sign. Okay, you have got this negative sign. Suppose imagine now let us plot a graph and show V of B is greater. Okay, V of A is greater than. How can you draw this graph? Just imagine x of A is equal to 10 meters. Okay, 10 meters and x of B is equal to 40 meters. This train moving with the velocity of what? Just imagine this train moving the velocity of 20 meters second and this train moving with the velocity of 10 meters second. Now this make a graph like this train. A train started at 10, 20, 30, 40, 50, 60, 70. Okay, students. This A train started at this distance and it went like this. Okay, easy. Now the train at 40, the train B, this is what that train A, this is what train B for your object B. So it makes like, it go like this. Okay, now at point something 1, 2, 3. Okay, at third second, at second 3, it both interact and what is the main distance? 60 meters. Or if it comes this side, it will become 70 meters. This kind you can easily got answers. So now we will find velocity at this point, what will be the velocity at that point and position at that point. So velocity at that point, it will be like V of AB. Okay, V of AB, and V of AB is equal to V of A minus V of B. So V of A is 20, V of B is 10. What it will become? Like 10 meters. Okay, students, at this position the velocity of A absorbing from B, it will be this, and velocity of B absorbing A, it will be like V of B minus V of A. How it will like 10 minus 20. What it will be like? Minus 10 meters second. And you know, we are traveling from a positive direction, so it can't be negative. So it will be like magnitude, it will be like similar. So at this position, the both velocity, the absorbing from one absorbent to another and other one absorbing the same absorbent, it will be like same, constant. Okay, students. Now you have got this value also. Now let us find that one. How it will find? Like, it's just simple. If you give positive value for this, give negative value for this, then see what will happen. Okay, now just substitute this in that and see what have happened. So if you substitute negative value, what will become? Positive, it will become. Okay, student. So just imagine similar case, we have given these values. What? X of A is equal to what you have done? 10 meters. Position, x of b is equal to initial position. What are those? These are initial positions, and x of b is equal to 40 and v of a is equal to what you have given here. What we have given is 20 meters second. So now just make v of b is equal to negative. What? Just simple. Okay, we have made negative. Now just solve this in that and see what will the graph it will be like. This graph will be like this kind. Starting from 10, it will go like this, and this is negative because velocity is going towards negative. It will be like from 40 to this kind of graph, because this is going up, this is going positive, and this is going negative. At a point 2 second, it will meet. You can write anything for your reference. We have written that they meet. Now just we find how it have done something to the problem. How? Just simple. Substitute these values in this. We will find velocity at this and see what had happened at that position. V of AB is equal to V of A minus V of A. This is a standard we are having. Now just substituting that V of A value, what you have, V of A 20 plus minus V of B minus 10, what you have finally got answer is 30 meters second. Okay students, now we have got this kind of value. Now just see this position we have observed from A to B. Now just observe from B to A. What it will be like? V of B minus V of A. V of B, what we have? V of B is minus 10. Minus 10. V of A, what we have? 20. No negative sign. So it will become minus 30 meter second inverse. So here positive, here negative. And you know that speed, the position is moving upwards or it is moving forward, so it can't be negative. So magnitude of this will be like similarly. Okay students, so in this case this value, the velocity at this position is greater than the magnitude of this or magnitude of A. How? Just simple, the magnitude of A, it will be 10. So at this position, this position velocity is greater than the magnitude of this and this. Okay students, so always remember a point at the coincidence position, the both velocities, the observing velocity from A to B or B to A, it will be same. Okay, just simple as it is. Now these are the formulas, these are the graphs. So until now we have discussed some good topic. I hope you like this video. If you have watched this video until this, so please like and share with your friends so they can also get the benefit of this video. And very thank you. We will meet you in next class. Salute.